Who would have thought that just trying to replace this little aluminum tube with fittings that went from the pump to the tank would have been such an ordeal of trying to find and figure out all the parts. This is for my Craftsman compressor, specifically that one, the model 919167280. So initially, because I measured this, and again, this is because I don't work on this stuff, so I don't know these things like a lot of people who work on this stuff all the time would know. I didn't know if the outside diameter of the pipe is 3/8, that means it's a 1/4 inch, and I figured, oh, that's 3/8. No, that's 1/4 inch. They go by inside diameter. And then I figured, okay, well, I'll order, again, going on the mistaken assumption that this was a 3/8 line, I figured, oh, okay, well, that fitting looks bigger than a 1/4 inch. I'll see if that's 3/8. No, it turns out that is a 1/4 inch NPT, not a 3/8. So, okay, fine. And then I thought, well, maybe it's the same on both ends, just one's the male and one's the female or whatnot. Nope. This end is a compression fitting on the other side. So that's a compression fitting and a compression thread, which is completely different. So I went from trying to get parts from one end to the other to, oh, I need different parts over here, order that. And then, oh, that doesn't fit here either. And then looked online, and you can't get these anymore because it's an old compressor, which is fine. It's been taken care of, so it should be fine. But then it's like, okay, if I want to replace this, what kind of part is that? I don't know. It took me a half hour to figure out on a parts diagram what this part is called to try and get a different one. Because I really don't want to have to deal with compression fitting. Because if I have to do compression fittings, I'm going to have to go back to hardline and then back to this, which is one extra step. So I hope, we'll find out. I think I now have parts that will go from here into a hose, which will be this. Then the hose will go to a fitting like this, which will screw onto here for the radiator. And then another of these fittings to go on the radiator that comes out to go to hose that will then go to one of these, which then goes to the side of the final dryer piece. And on the other side is the other piece of this that goes in the other side. And from that goes to hose, and then here, and then this will screw into that, and then that will replace the piece that sticks in the tank here. And then I'm really hoping that this will just screw into the side of this one because it does have the hole on the side for the 1/8 inch tube. And I also got, because this style compressor does not, this spins, but the goal is to try and put the plastic casing back on so that I'm assuming they had this casing set that when this spins, it helps cool the motor. And if I take that off, the motor will not get as cool as it did before. So I'm going to try and put the casing back on, which means I can't use this fan to cool the radiator. So I got a fan for the radiator, and I got the connector stuff that's supposed to let you connect this into here without damaging this. And then because this has 12 volt, 80 watts, I got a power supply to go with it because I don't want to have to route it up in, and I'm sure I could open this box and maybe route other cables in there, but it's probably better to just not do that since this is really small and just keep all that stuff separate. So to start, I take the pieces out and replace it, and that worked, amazingly enough. And then I take all that stuff off so I can get access to things, because then I realized I can't put the 90-degree fitting in there with the motor in the way. So then I took that off, put that back on. At least now I know how the motor goes on and off. Get all that stuff reinstalled. That all worked okay. Put the other fitting in, and then just try it with the hose as is and see. A couple reasons. One, is it going to work at all just with the hose? That worked too well so far, so I should jinx it and say, oh, this is going well. This part went in, the hose clamp worked. This new piece went in, and that elbow worked, and the hose clamp on there worked, and this 1/8 piece went back in. I put some air in, sprayed a little bit of soapy water on the connections. Next is I have to figure out how to get this, how and where to get the radiator attached. Oh, and this is the piece that came out. It's slightly corroded. And now that works like there, start working and figuring out how to get the radiator and such installed. And I realized I need another piece, so I had to go bend metal, get a piece of sheet or a piece of board to do the other side, get that all sorted, get that reattached. Realized in there that I put it on the wrong way, had to take it apart and redo it again. Measure, draw, drill. Figure out how the little specialty pieces for holding the radiator on work, and then drill holes so that those will fit through. Get that stuff sorted. That looks like it will work. And realize the camera was in the wrong position. You can't see what I'm doing. Add another horizontal stabilizer to hold the wood in place. Get those pieces in. Radiator looks like it'll work. And the one thing I probably should have planned on, which I didn't because I wasn't sure where this was going to go, was where to put the filter. But I may have gotten lucky, and those bolts are the same size as the filter bit, so I might be able to just attach the filter here and it'll hang there. That's what I'm going to try next. I'm going to see if I can get this on there. And now I get to figure out and install the air filter piece. That worked. Got that going. Then start doing the other fittings. And that seems to be going okay. Put the Teflon tape in the various fittings. And I'm also trying to make sure that I get the sizing right for the hoses, so I cut and waste the least amount of hose. And then I test it, and that seems like it sort of worked. Now I get to work and figure out where to put the fan. So I got the fan installed with some zip ties and pieces, and then realized I need another board to install the power supply for the fan. Got that installed. And figure out which way the fan is supposed to blow. And once I got that figured out, then I know which way to do it. Then get that all crimped together. Well, that worked awesome. Initially I had some leakage around these two spots, and I just tightened it a bit more and the bubbles went away. These were tight, these were tight. The one thing I remembered, almost too late but not too late, was because this is a fragile tube, you have to have a holding wrench here while you're tightening. I went and I saw that this was starting to twist. It's like, no, don't do that, and put it back. But that's all tight. I had enough hose. I think this is going to work fine. These hoses are touching, but those are both cold, so it won't matter. The hot hose and the cold hose don't touch, so that's a plus. I managed to get the power supply working, and I have the fan so it blows across the coils, and I was able to just zip. They have extender pieces for the fan, and I was able to just use some zip ties on that. As we said before, this came out awesome. I just happened to get that right, so the spacing for that worked. I just used some screw eyes to hold the pieces for the fan. As you can see down there, there's a screw eye. This side, on this corner, I just connected the fan to this L bracket that I made, or bent up and made. And yeah, I think that's awesome. These little things worked. So it doesn't, it vibrates slightly, but the whole thing vibrates slightly. Nothing vibrates more than anything else, so I think that's going to be fine. Because these are flexible hoses, even if it's vibrating like this, the connections will stay solid. And because they're flexible hoses, it won't wear out. And because these are hoses from like an engine, they would be, engines vibrate all the time, and those things last for years. They age out and dry rot before they vibrate to pieces. So, and there's nothing that's going to be friction. There's no friction that's going to hold against these or rub and wear. Everything's held separate. This is awesome. As I said, I made a little L bracket. I had some pieces of, I don't know what this was from, but I kept that because, you know, materials are useful. And so I just bent a piece on this side, and that all worked. The fan works. The one thing I'll have to do is, because as soon as you plug this in, the fan runs. Push. So there, that runs. And again, that's pulling air from this side through and blowing it out over here. So that's going to work great. And now we're going to do the full test and see how that goes. And then I realized the hose pops off, and that's not good. So then I try and tighten up the hose clamp, and the hose pops off. And I try it again, and the hose pops off. So there's definitely issues. But I don't know if it was on any of the other video pieces, but I also, when I was leaving this sit overnight, I noticed that the pressure dropped because I left this at 75 and have not let air out, and it's now, that was yesterday evening, and it's now down to 45. And the problem is this red fitting is leaking in this crack. Either when I loosened the old one up or put the new one on, that must have loosened this just enough that it cracked whatever seal was in there, and it's now doing really tiny slow bubbles. So then I try and take things off to get the piece going into the tank sorted. I got it off, had to take the motor off, did that. Tried with a bunch of wrenches, could not get that off. So after a bit, gave up on that, decided, alright, I'll try and work on the fitting. I made a whole lathe video on that has a little bit slower. So then I get the tank again, get that all cleaned off. And there you go. It looks, paint's all cleaned off and dug out around in there because I'm going to try and put epoxy in. Get some of the JB weld in around there. That at least works. So now once the epoxy's all cured and dried and such, put everything back together. And we'll try this again. Get all the fittings, all the parts back on, get things going. And it still fails. Well, one of the two problems is solved. The JB weld looks like that sealed this part nicely. Just having a plan doesn't always work, but we're going to try it anyway. So we got the two parts in. I got the better hose clamps. I tried with the better hose clamps. These are the extra strength hose clamps. Or actually first, yeah, that was with just the old hose clamp. And then I figured, all right, we'll try it with, and we'll wire it in to see if that'll hold it a little bit better. And you can see it's going and going, and you watch real close up there with the better hose clamps, and it's starting to slide, but the wire kept it from coming off. But if you look real close right in that section, you'll soon see the hose fails. See there? I'm trying to do leak testing because it's sliding a little bit, but the wire is keeping it in place. There you go, the hose failed. That didn't work. Yeah, that didn't work. So I got new heavy-duty hose clamps. I had a new piece of hose, a new fitting, and it was still sliding off with just one. So I shoved things back up, tried it with two. It was still moving with two. Probably should have done a new hose at that point, but I figured, all right, let's just see what happens, because the problem is it slides off. So if we can keep it from sliding, maybe there won't be an issue. It may hold it tight enough. So I tried putting wire around it and tying it around the cylinder head gently but securely. It avoided it coming the whole way off, but as you see over here, it blew out at least part of the other part of the hose. So I'm pretty sure this hose is trashed at least back to here, and it's also still really hot. That says 90 degrees. Oh, there we go. Yeah, 130, 140 something. Yeah, the thermometer thing doesn't do very well on hoses and such. See, that's like 148, 150. Good news is that's 72. That's 85. So the cooler is still working successfully. The problem is this thing won't stay on. So I think I am done and out of ideas for trying with this. This hose is supposed to be up to 300 psi, and it's supposed to do up to 257 degrees. I'm only seeing 150 something with this, but maybe it gets hotter down in the hose and has issues. It may also just be that this does, because this compressor vibrates so much, the vibration plus hose means the rubber just doesn't deal well. So I think the rest of the system is probably okay, but I need to come up with another method of somehow going from the pump to the input side on the radiator, because I don't think this hose is going to work. So it wasn't just that I had a defective fitting, because this is a different fitting that's holding, well, we didn't actually use this one anywhere, but this fitting sizing is similar to ones down here which are holding fine at the same pressure. But maybe this has less vibration because it's down on the tank versus on the right on the pump itself. I don't know. So, yeah. This is frustrating. Alright, so we're going to do the final fix here. I went and bought a McMaster Carr industrial type hose that'll work up to like 1200 degrees. It's for steam and hot air. That will work. And there's fittings that will work. And then I ran it, and it went from empty the whole way up to full, and there were not leaks, which was a big improvement over before. You can see how everything vibrates like crazy on high speed, but there was no leaks. You can also see it hit 256 degrees on the top of the head. That's really hot. And the input of the cooler is like 90 something or 100 and something. I don't know. This doesn't work good for round fittings. But you can see it goes from hot before the cooler to cold after the cooler, and it cools down clear till it gets to the tank. So that's probably warm because it was next to the motor and such. But yeah, the fact that that was really hot, that was the failure point. Well, this has been a very frustrating and annoying process that should have been simple but wasn't, due to failures of Chinesium parts off of Amazon. I finally got everything connected thanks to a McMaster Carr high pressure, high temp pre-made hose. Initially, I had hoped that this would go right in here, because this is supposed to be quarter NPT to half inch, and then I could have skipped this, and this would have been over more, and I theoretically could have been able to bend that down around. But because this is out so far, and this is still really hot, I don't know that I'm going to be able to bend this down around to get it out through the plastic piece. But this is the first time I was able to run it from empty to full, and when it shuts off, so it shuts off at about 145, and it didn't leak. It didn't leak in any of the fittings. This fitting didn't pop off like it had every single time I tried with the rubber hose and the barbed fitting, but it worked. So the way this ended up working, I ended up having to get from Home Depot, just because I got tired of waiting on Amazon and I was afraid I was going to get the wrong stuff yet again, or the missized stuff. So I got a quarter MPT to quarter MPT adapter set. One of these little things from Home Depot. It has 2 male to male and 2 female to female, and I used one of each to basically split it out and get a longer female section that I was able to get the bad fitting in, and then that connected to the really awesome McMaster Carr hose out and around. So this is a quarter to quarter NPT male to male, quarter to quarter NPT female to female, quarter NPT to half inch NPT, half inch NPT input to the high pressure, high temp hose. That hose is rated for steam and such, so it'll do like up to 1200 degrees. As you saw, it got up to over 250 on the input here. So I think that was why the rubber hose was failing, because that rubber hose was only good for up to 255 or so, and it was right at the upper end of the temperature range. So I think that's why the rubber hose kept failing, plus the fact that I couldn't hold it well enough onto the fittings after it got soft at the upper end of its temperature range. But then I go 1/2 inch NPT to 8 NBR or something like that, and then down through 8 NBR or something like that to barb, 1/2 inch barb, over to 1/2 inch barb to 1/2 inch NPT, 1/2 inch NPT to barb hose back around, back to 1/2 inch NPT right angle to 1/2 inch NPT down to the 1/2 inch NPT on there, and that just has the 1/8 inch connection. And it reduces the temperature from like closer to 200 down to like 80 degrees. And just with that full filling, let's see if this actually works. This should be a 1/4 turn or so. And do I have, yes, hold on. Okay, I do have a bowl. This is how much water the filter separator pulled out just from an empty to full filling. Not a massive amount, but that's that much water. I mean, that's decent amount. So it pulled that much out instead of it going into the tank. So you figure this process worked to keep that much water out of the tank, which is awesome. So I still have to figure out how and if I can get, because since this is set up such that it's still hot, there's this sharp bit where the plastic comes across. Like I said, I don't know if I can get this bent down and around. Maybe it'll work, but that's kind of pushing it for how it wants to bend. You can see that this part doesn't want to go, so I may have to just loosen this fitting. Ow, that's still really hot. That's probably well over 130 degrees still. So I can loosen that, and then maybe it'll bend a little bit better down around. So I still have hope for that, but I can't leave it like this, and that's why I had the t-shirt there, because a sharp thing with vibration will cut through most things. The process worked. It cooled it from can't touch the top, 200 degrees, etc., to 80, and then it pulled the water out. It's a successful, if extremely painful process, but it would have been nice if the ones that I bought, I don't recommend this brand at all, or SDTC Tech, made in China. These do not work by themselves, or at least these do not go right into the compressor. I was able to get the one from Home Depot to work just fine in the compressor, but those do not. They did also end up going entirely, even when I had trimmed that one off some in the lathe to try and see if that would help. It went entirely, almost clear up to the fitting shoulder in before it got mostly tight. So yeah, that because this was only doing like 5 threads, there was no way that was going to work in here. It's mostly done. I still have the plastics to play around, and I'm not even going to bother to video that because I don't know how that's going to work, and that's not the interesting part anyway. The interesting part was trying to get all this mess done. There you go.